Alright, today guys we're going to learn how to divide polynomials. So there's actually three strategies for dividing polynomials. The first one is dividing a polynomial by a monomial, which is pretty straightforward. But then there's long division and synthetic division. So pretty involved lesson for today, but not too bad. Hopefully you can relate it to what you already know about division. So let's cruise right into it. First of all, dividing polynomials by monomials. All you have to do is divide each term in the polynomial by the monomial. So if you see that you're dividing by one term, one monomial, the division's pretty simple. Let me show you. So what you would do is, like in example 1a here, and again I encourage you to fill out your notes and do this along with me. But to do this one, what you're going to do is you're going to take each piece in the polynomial and divide it by this monomial. Okay, so we're going to divide each piece by 4cdf. Okay, so when we do that, now just like what we did yesterday, right? So, or last time. So 20 over 4 is 5. C to the fourth divided by c is c to the third. D squared divided by d is d. And then f divided by f is just nothing, right? It's just 1 actually. So we're just going to leave it like that. Okay, so we have 5c to the third power d. Okay, then we're going to subtract here. 16 divided by 4 is 4. C over c is just 1, so we're going to leave it. D over d is just 1. We'll leave that. And then we're just left with the f. Okay, and then here, 4 over 4 is just 1. So we have 1. C over c is 1. D over d is 1. F over f is 1. So we're just left with 1. So that is our answer. All right. And then for 1b, notice it's a multiplication problem, but here's the problem with 1b. This is taken to the negative 1, right? If anything taken to the negative 1, what that means is it's 1 over 3xy, right? That's how I could rewrite that thing. And now if I multiply it out, what I'm actually doing is dividing, right? So let me just show you. It would be this, just so you're clear. That's the math that's happening here. Okay, so these cancel, and now I'm left with the division problem, right? So I'm just going to divide each piece in the polynomial by 3xy. So if I do that, 18x squared y over 3xy plus 27x cubed y squared is z over 3xy. Okay, this turns into 6x. The y's cancel. So we just have 6x there. And then here we have 27 over 3, which is 9. X squared, y, z. Alright, so that's dividing a polynomial by a monomial. Now, this is where you need to pay close attention. We're going to move into long division. Okay, so there's a number of steps here for long division, so I'm going to go over them really quickly, and then we're just going to get right into it. So, steps. First of all, you're going to write the polynomial in descending order, starting with the highest degree. If any terms are missing, this is very, very crucial that you get this. If any terms are missing, you're going to use a 0 to fill them in. Okay, so for instance, if you had 4x to the third minus 2x, okay, if you're doing division here, we have to hold place values for every missing degree. So notice they put a 0x squared. There's no x squared terms, so we have to hold the place value there, and I'll show you why that is in just a minute. Number 2, divide the term with the highest power inside the division symbol by the term with the highest power outside the division symbol. Okay, again, that'll make more sense here in a minute, so we'll refer back to these. Number 3, multiply. Okay, so remember, does McDonald's sell cheeseburgers? Kind of the same deal. We're going to multiply the answer obtained in the previous step by the polynomial in front of the division symbol. Subtract the next term, bring it down, and then repeat the process. So here we go. This is how this looks, you guys. For 2a, okay, we're dividing this polynomial by, this is not a monomial anymore, right? This is a binomial. So we're going to use long division. since it tells us to use long division. So we have x minus 3, and we're taking that into x squared plus 7x minus 30. So what we're going to do is, we're going to look first of all, do we have all of our placeholders? We do. We have an x squared term, an x term, and then a constant. So we're okay there. Okay, and then I'm going to take my first term here and into my first term here. So x goes into x squared x times, because x times x is x squared. So that's all I do. Okay, I put an x up here. Notice I put it in the next placeholder, so I put it above the 7. So x, and the reason for that is I'm going to multiply out the x by both pieces here. So x times x is x squared. X times negative 3 is negative 3x. And then I'm going to subtract like I've always done. The first piece should always cancel out. Then I'm left with 7 minus negative 3, which is positive 10x, and then I'm going to bring down my next term, just like you do in regular division. Okay, and then x goes into 10x 10 times, so I'm going to say plus 10 here. 10 times x is 10x, 10 times negative 3 is negative 30. When I subtract here, I'm left with 0, and this is my answer. Okay, so if you took this x plus 10, multiplied it by x minus 3, you should get what's inside. Alright, so you can actually check your answer and do that out. Let's try another one here. So for 2b, we have x minus 1. We're going to take that into x squared minus 13x plus 12. Alright, so x goes into x squared x times. Okay, and I'm left with minus 1x here. We subtract. Negative 13 minus negative 1 is negative 13 plus 1, which is negative 12x plus 12. I'm going to bring this down. X goes into negative 12x negative 12 times. When I multiply that out, I get negative 12x plus 12. When I subtract that, this goes away, oops, sorry. And this is my answer. So again, x minus 12, if you multiply that by x minus 1, you should get this back. Okay, so we're using long division to kind of actually factor this, right? It's a form of factoring actually, and I'll talk more about that in a future lesson. But anyway, example 3 says which expression is equal to this guy. Okay, so remember when you take something to a negative 1, this is multiplication that's happening, but to a negative 1, it's the same thing as 1 over that guy, right? So this is actually going to be division. So we have 1 minus r, and we have to divide that into r squared plus 5r plus 7. Here's the problem. I can't take my 1 into r squared, so I'm actually going to rewrite this. So I'm going to use an eraser here just so I don't have to rewrite the whole thing. And I'm going to rewrite it as negative r plus 1, which means the same thing. Okay. Alright, so to get r squared, you could take negative r and multiply it by itself, right? So to get r squared, so we can put in a negative r in here. Negative r times negative r is r squared, positive r squared. Negative r times 1 is negative r. If we subtract here, we're left with 6r. Bring down our 7. Okay, and then negative r goes into 6r negative 6 times. Negative 6 times negative r is 6r. Negative 6 times 1 is negative 6. Subtract. And this goes away, and then I have 7 minus negative 6, which is positive 13. And notice this is the end of the road because we've already brought down everything that we could. So what do I do if I have a remainder? We haven't talked about that. So what we do with a remainder here is what we did when we had a remainder in any long division problem early on in elementary school. We don't just write remainder 13, we turn it into a fraction, right? Where we have this piece over this piece. So this becomes 13. So we're going to add this in plus 13 over, actually, since it's a negative here, we could just do we could just subtract this, I guess. So if we subtracted this, well, either way you do it, because we have to look to see what we have there. But if you, typically you would add in the remainders. So it'd be 13 over negative r plus 1. Okay, so do we have that in one of our answers? Technically, I guess we do, because with this guy, it's the same as this. They just reverse the order, right? So it's negative r minus 6 plus 13 over 1 minus r. They just reverse the order of these two things. So right here it works for f. All right. So that's example 3. Now, you guys, synthetic division. I know this is going to be a long lesson. So synthetic division. There's another way to do division that a lot of students like better, and it's called synthetic division. Okay, so here are the steps to it. You're basically just going to write the coefficients of all of the dividends so that the degrees of the terms are in descending order. So again, you have to make sure you have a placeholder if you don't have every single degree represented. Okay, then you're going to write whatever makes the divisor go to 0 in this little box here. So this is what it looks like. So for this one, we had x minus 4. So what makes that go to 0 is just 4. So 4 goes in the box. Okay, it comes from right there. Then notice what they did. They took the coefficients in front of each piece, right? So 2 went here. Okay, the negative 13 went here. The 26 from up here. Oop, what happened to all my pens? The 26 came down here, the negative 24, I think you get the point. Okay? So once you've done that and set it up, then what you're going to do, it's very simple after that. You're going to bring the first term down. So you bring the 2 down in this case. Then you're going to multiply. 2 times 4, you get 8. Then you're going to add. You're always going to add. No matter what, you're going to always add. Okay, so negative 13 plus 5, or plus 8 gives you negative 5. Okay, so you add the product to the second coefficient, and then you just keep repeating this process over and over and over. Negative 5 times 4 is negative 20. Notice that's what they put there. Add those two together, you get 6. 6 times 4 is 24. What do you have left? 0. So this is kind of the process and what it looks like. And why we do it is it's easier and faster later on when you have long problems. So let's take a look at 4a. Okay, what makes our divisor go to 0 is negative 3. So I'm going to write that in the little box. Okay, and again, I encourage you to follow along and do these in your notes and just get the process down. Okay, so here we have a 2 in the x to the third, and then we have a 3 x squared, and we have a negative 4, and we have a 15. We have a placeholder for everything, so we're good. We're going to bring down the 2. 2 times negative 3 is negative 6. We're always going to add. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. Okay, 9 plus negative 4 is 5. 5 times negative 3 is negative 15. And we're left with 0. Our answer to this, you guys, now, is we've taken this x plus 3 out of this, right? We've taken it out. So everything has to drop by a degree. So my answer to this is 2. I started with x to the third power. Now it's going to turn to x squared minus 3x plus 5. If I take this and multiply it by this, I should get that. Okay, so if you want to FOIL it out, you can and see if that worked. So that's 4a. 4b, let's try another one here. We have 2 going into 3, negative 8, 11, negative 14. Okay, bring this guy down. 3 times 2 is 6. Add. We have negative 2. Negative 2 times 2 is negative 4. Add those together, we got 7. 7 times 2 is 14. And we're left with 0. So we have 3x squared minus 2x plus 7. Okay, that's your answer. So kind of fun, kind of a lot faster than going the other way with long division. Let's see what we got here. 4c, what are they giving us here? So negative 2. I want to show you one where you don't have every placeholder. So this is one of those. You guys got to be really careful. We have 4a to the fourth, but then we have no a to the thirds. So we have to put a 0. So this is like a to the 4, a to the third. There's none of those. And then we have 2a squareds, negative 4a's, and then 12 constant. Okay, so this piece 4c is important because they're showing you what happens if you have a degree missing. Okay, so here we go. We have 4. 4 times negative 2 is negative 8. We're adding here, so this becomes negative 8. 16, 18, negative 36. So what is that? Negative 4 plus negative 36 is negative 40. Negative 40 times negative 2 is 80. Okay, add those and we were left with 92. So let me just make sure I didn't do that wrong, because we can easily do something wrong, but just want to check to make sure that they're showing you remainders. They are. So my answer to this is 4a to the third minus 8a squared plus 18a minus 40. Okay, then we're going to add a remainder, 92 over a plus 2. And what that means is it just wouldn't factor nicely or perfectly. Okay, so a plus 2 is not a factor of this thing. All right, let's keep going. Let's go to 4D. Okay, so this tells me that 2 is what needs to go in the box, right? Because 2 is what makes that go to 0. And then I have 6, negative 8, 0. Be careful there. This is the one that's most missed because there's no square term. 12 minus 14. Okay, so again, bring down. Okay, and I'm just going to do this a little bit quickly here. So we have, what is this? 4, 8, 16, 36, and then we're left with, let me just make sure this is what I wanted to do with you guys. Yes, we're left with, did I do, oh, that's not right, is it? Sorry, this is 56, not 36. We had 28 times 2. Okay, there we go. Now we have 42. Okay, so final answer for this one, we have 6b to the third plus 4b squared plus 8b plus 28 plus 42 over b minus 2. Whew, okay, I think that's it for example 4. Oh, and then I have to show you one more example, you guys, sorry, and then I won't do all of these, but we'll do one of them at least. What happens if the coefficient is other than 1 here? Okay, so if that's the case, we're going to make that coefficient of the x term 1. Now, what I typically tell students is, if you're doing synthetic division, sometimes it's easier to choose to do long division if this thing is other than 1. Okay, it's really up to you. Like because what you'll see here is that you're going to be dealing with some fractions when we do this. So it's up to you. You could do it either way. So if I want that to be a 1, I have to divide both of these by 2. Okay, so if I do that, I get x plus 1/2. All right, so that's going to be the exact same thing as 2x plus 1. All right, so now I can use that, and I can say, okay, in my little fraction box, negative 1/2 is what makes that go to 0. And I guess, you can also think about it as, negative 1/2 is what makes this go to 0, so you don't have to rewrite that. It's just whatever makes this go to 0, right? But anyway, so you have negative 1/2, okay? But then, don't forget that if you divided this by 2 here, we also are going to be dividing everything that we see by 2. So this gets divided by 2, this gets divided by 2, this gets divided by 2, this gets divided by 2. Okay, so since we modified that first thing, we got to do it to every piece. Okay, so let's do that. For this one, we get 4. We have no x to the thirds. Okay, 4 divided by 2, negative 4 divided by 2 is negative 2. And then we have 1/2, and then we have 2. I don't know why I put a plus sign there. We understand it's plus. Okay, here, bring down your 4. 4 times negative 1/2, negative 2. Add it. Negative 2. Remember, we're always adding. Negative 2 times negative 1/2 is 1. Negative 2 plus 1 is negative 1. Negative 1 times negative half is 1 half. So we get 1. 1 times negative a half is negative 1 half. And then I'm left with, what is that, 1.5? Or 3 over 2. Okay, so what I'm going to do now is I'm going to rewrite this whole thing out. Okay, so I have 4x to the third minus 2x squared minus x plus 1 plus, and remember here that what I'm going to need to do is take my, since I divided by 2 in the beginning, one strategy, if you want to use this thing again, this original here for the remainder, you can multiply by 2 here at the end. Okay, so if you do that, you're left with, this is technically 3. So you'd have 3 over the original, 2x plus 1. All right, so that's probably the easiest strategy for what to do with the remainder on that one. Okay, for 5b, I don't know that I'm going to get into this one, you guys, just for the sake of time. But here you would be dividing by 4, so things just get a little bit crazier because you're dividing by something other than 2. But that's what all these examples are. So I'm happy to work these in class, but this video is getting too long, so we'll do some more in class.